So the capacitance that we have here is 4 microfarad is going to be equal charge divided by the volt. That's 9 volt. So the charge will be equal 4 times 10 minus 6 farad multiplied by 9 volt, and the charge will be 36 times 10 minus 6 coulomb. That's one thing. Amp is going to equal volt divided by a resistance. So the current in the circuit is going to be equal 9 volt divided by the resistance of 25 ohms. So the amp will equal 0.36 amps. Okay, from here we go to question B, and this one we're gonna use the time constant formula. So that has to do with the RC circuit formula discharge, and that's Q equal initial charge, invert natural log function, power of time divided by time constant, and this will give us charge. What's the initial charge? That's 36 times 10 minus 6 coulomb. The invert natural log function, power of minus, what's the time? The time that's for the B is 50 microseconds. 50 microseconds divided by time constant. So we can do the time constant will be equal resistance times capacitance. So we know the resistance is 25 ohms multiplied by 4 microfarad, and the time constant will equal 1 or 4 seconds. Okay, so if we can put it down again, it's going to be charge. The initial charge is 10 minus 6 coulomb multiplied by the natural log function of minus 50 times 10 minus 6 second divided by 1 times 10 minus 4 seconds. And this charge is supposed to give us 21 microcoulomb. Okay, and then we can use the capacitance multiplied by capacitance is equal charge divided by voltage. So we have to, the capacitance 4 microfarad is equal the charge, the new result of the charge divided by volt. So we can find this volt here. So the volt will be equal to, so the volt will be equal 5.25 volts, and then we can use this one to find the amp. That's 5.25 volt divided by the resistance, so that's 25 ohms. So the amp here will be equal 0.21 amp. Okay, if you go C, same thing, we have to do the charge is equal initial charge times natural log function of the invert natural log function, power of the time, that's 200 microseconds, divided by 1 times 10 minus 4 second. So the charge will be equal 36 times 10 minus 6 coulomb multiplied by the natural log function of minus 2 times 10 minus 6 second divided by 1 times 10 minus 4 second, and this charge will be equal 4.8 microcoulomb. And then we can find the volt, that we go from capacitance equal charge divided by volt. So the capacitance is 4 microfarad equal the new charge of 4.8 microcoulomb divided by volt. Just to make it clear, always have to convert microfarad and microcoulomb to farad and coulomb. So what I mean is that 4 times 10 minus 6 farad equal 4.8 times 10 minus 6 coulomb divided by volt. So the volt here will be equal 1.2 volts. And then you can use the amp equal volt divided by resistance. So the amp here will equal 1.2 volt divided by 25 ohms, and the amp will equal 0.048 amp.